Hey YouTube, welcome back to the Wireshirt Coders channel, and we're continuing on with our series to do with web APIs. This is part 1 where we're actually going to get down to doing some coding. Previously we discussed what we were going to do, so let's stop the talking and get on with the coding. So what will we be doing in this video? Let's have a quick look. So most importantly, we're going to start writing some code. We're going to create the solution required for the API series. So this is going to be file new project. What we get out of the box. We're going to create a class library as well. We're going to create a ASP.NET Web API project. Have a brief look at models, i.e. the data that we want to hold in our web API, and we're going to have our first web API endpoint by the end of this session. Just a quick reminder what we're building. We're building a sports management system that consists of fixtures that a sports club plays and players who are part of that sports club. Eventually we can have something in between called availability, where a player can say he or she is available for a given fixture. But that's out of the scope at present, so our focus is around fixtures and players and creating those endpoints we need to submit and view data. And we're going to start by creating a solution, a blank solution. We press next and then give it a name, so it's a sports management system. Go create. That will create us a solution. At this stage we have no projects in our, but what we're going to do for this whole series is we're going to have a web API project, and we're going to have a shared class library that's going to hold our business logic, our database access, our models, our DTOs or data transfer objects, and any other bits and pieces that can be reused in other areas. So that's what we're going to do first of all. So we're going to right click on the solution, we're going to go add new project, and we're going to search for a class library, and this top one is the one we want, a class library, a project for creating a class library that targets .NET or .NET Standard, and that is in C#. So this class library is cross-platform. As you can see, it will work across Android, Linux, Mac OS and Windows. So we'll just select that one, and what we will do is we will give this the name Sports Management System Shared, and click next. We're going to use .NET 7, which is the latest version of .NET at the time of recording, and we're going to hit create. Visual Studio go away and work its magic and set up a basic class library template. The class library template is very simple indeed. It just literally has a sort of default class in there that we don't want. So the first thing we're going to do is we're going to delete that, and then what we're going to do is create some initial folders in the shared class library to sort of segment our code into more logical sections. So as I described in another video, RESTful web APIs are in .NET are based around the sort of idea or paradigm of MVC, Model View Controller. So in our shared library we're actually going to place our models in here. So the first folder we need is a models folder. So we're going to right click, add new folder, and call this models. We're also going to add some other folders that as we progress through this series will get populated as well, but we're just going to do the groundwork now. We're going to have another folder, and we're going to call this one DTOs. DTO stands for Data Transfer Objects. I'm not going to go into any more detail about these now. That we'll have a dedicated video later in the series to do with data transfer objects, but we need a folder for it, so we'll create that one. We're also going to have a folder that's going to hold all the logic for talking to our persistence layer or database layer. In the early stages of this video series, we won't be using an underlying database to store all our sports management data. We're going to hold everything in memory, but again, planning ahead for the future, we'll eventually end up saving, retrieving, deleting and updating our data from an actual database store. So again, this is setting up the groundwork. So again, we're going to right click on the shared project and go add new folder and call this data access layer, or we'll shorten it to DAL. And possibly one other folder we'll create is one that's going to hold our logic. So again, I'm going to right click, add new folder, and we'll call this logic. It's as good as anything, so let's call it logic. So that's our structure for our shared library. What we're going to do now is we're going to create a couple of classes in the models to do with our sports management application. As we stated before, our sports management application consists of 3 components. It consists of fixtures that the sports club need to administer. It consists of players within the sports club, and the sort of final part, which may or may not be within the scope of some of these initial videos, is the availability. So a player will be able to state which fixtures they are available play in for those particular matches. So for now, I'm just going to create 2 of those 3 models, a player and a fixture. So how we do that is we go into the models folder and we go right click, add class, call this player, and we change this to a public class because we want to be able to access this particular object outside of itself. And all models are basically fields or properties that describe the sort of things that we're trying to hold data about a player. So for example, a player will have a name, they may have an email address, they may have a mobile phone number and things like that. So let's just for now just create a few dummy properties. Again, we may revisit this later video just to flesh it out further, but this is just literally trying to get us up and running with something in code. So in order to create a property, you can use the Visual Studio snippet shortcut, which is prop followed by tab, and that will stub out a basic property. The next part is you need to specify the data type. So I'm going to say this is a string, and it is going to be the player's name. In fact, let's split this out further and let's split it into their first name, and then we'll create another property with prop tab string. Let's make this last name. Let's create another property of string email, and another property phone number, and one final property, and this one will be a true or false bool, and we'll call this is active is active player. So this will allow us to toggle on players so they appear on the only if they're active, and we can make them inactive and actually out having to delete all the information in the underlying database. So we can toggle players on and off from the UI. So that's why we put that one. So we've got a class, we'll save that one. We'll add one more model. So we're doing the two outer sides of the overall system. We're doing a player and we're doing a fixture. For this video we won't bother about the availability part yet, because what we want to do is get something up and running quickly in terms of a web API. So again, add class, and we're going to call this class a fixture. And again, we need to make this public. And we'll do prop, and we'll call this string. And when you have a fixture, some sort of sporting match, it must be against some opponent. So our first property will be opponent. Then probably another property of a fixture is the date it's taking place. So we'll make this a date, time, date of fixture, and another will be is the fixture being played at home or away. So at the moment I'm going to make this a string, but at a later date we may come back and revisit to see if we can have a more suitable type for this. We might be able to make this, for example, a enum or an enumeration that will allow us to specify only two values, whereas a string will let us type anything at this stage. But for now, a string is good enough. Also need to know when the fixture starts. So again, we'll make this a string. What else would we need? We may need a postcode. So if we're playing the game away somewhere, we need to know a location of where the away ground is. So in the UK we call that a postcode, a unique identifier. Probably in the States it's called a zip code, something like that. We could have a full address, but for now we'll just leave postcode. And one final one is a prop. This time it's an integer, so int number of players required. So to make the system have a bit more flexibility, we're going to say for a given fixture we n number of players. So this makes our system a little bit more flexible. So if we're playing in a team sport such as football or cricket, those teams as a standard need 11 players a side. So in our fixture we could say we're playing a fixture against ABC club, and it is a football fixture, and we need 11 players in order to have a full team to honour that fixture. Whereas if we were playing rugby union requires 15 players per fixture. Or if you're playing rugby sevens, it may become just 7 players per fixture. So it allows each fixture to specify the number of players that are required in order to fulfill that fixture. So that's why we've added this property. So at this stage, this is enough to get this up and running. There's nothing really should go wrong with this, so just as good practice we just do a build solution. Everything should build successfully. There we go. One other thing that I've noticed is well, I'd like to change the namespacing on these. So in order to do this, this is the old-fashioned style of namespacing. You just right click, quick actions and refactors, convert to file scope namespace, and that just gets rid of some of the indenting that we don't need. We're also going to do that in here. So again, right click on the namespace, quick actions and refactors. There we go. At a later date I will show you how you can have that as a setting for any future files, but for now that is sorted out our two files. So that's our one project setup. This project, being a class library, does not allow you to execute it on its own. The output from compiling this project is you end up with a DLL, and that DLL can be shared about by other projects in order to consume its content. So this is a background thing. This is, the user won't see any of the stuff that's in here. It's background logic that we can apply to another project. And in our case, this other project will be an ASP.NET Web API project. So that's the project we're going to create next. So on the solution level, if we right click and go add new project, and again if we search for ASP.NET, so this is the one we want, an ASP.NET Core Web Application. It's for C#, and again it's cross-platform, across Linux, Mac OS, Windows, Cloud, and all these other good things. So if we pick this one and pick next, again we need to give it a name, so we will call this Sports Management System.API. And we want this to be on .NET 7 standard. This stage we're not going to worry about authentication, that will come at a later date. We want it configured for HTTPS, and we don't want to enable Docker, and that's all fine. So if we go next, actually I've just spotted I've picked the wrong template, so it's not ASP Core, it's ASP.NET Core Web API, it's this one. So if we pick this, go next, repeat the steps, SMS API, next. That looks better. So now we've got the latest version of .NET, which is .NET 7. Again, we're not going to worry about authentication types. We are going to configure it for HTTPS. We're not going to enable Docker to start with. Can discuss Docker at a later date. We're going to use the traditional controllers approach rather than minimal APIs. Again, minimal APIs we can discuss at a later date as well. We are going to enable Open API support. We'll have a whole section on that at this stage. This is what will help us see our API, test it out, document it and things like that, but we'll go into further detail at a later date. The key thing to remember when setting this up is this one is always a good one to have checked. So Visual Studio has gone away and it has produced its out-of-the-box web API. So if we just set this as the start project, we can just show you what this looks like out of the box without us writing any code whatsoever, and then we can go away and clean it up a little bit. So we've set that as the start project. If we press play, the project will get compiled. That is my virus checker just scanning there, so we just can ignore that. Hopefully that shouldn't pop up again, so that's good. And then in a browser, hopefully, there we go, we get this pop-up. So what this is this is what this Open API is it basically creates living documentation of your web API. So the one that comes out of the box is a weather forecast, and it has a endpoint, a get endpoint, which allows us to go and get data from the server, and we can even try this out. So we can expand it and hit the try out button, hit execute, and you can see it comes back with a load of weather data. All this weather data is made up. It's just a little randomizer, so each time you run it you get something a little bit different. There we go, 40, 30 and so on. The interesting thing to note here is we get a code come back, HTTP 200, and we get the data, also known as a payload, and the data in this example is returned in a JSON format. So this follows along with what we understand of RESTful API at the moment. It is basically functions that are hooked up to HTTP verbs. So HTTP verb is a get, for example, which goes and gets the data. There is also a post that allows you to send data to the server and save it. There is also a patch, which allows you to update data that's on the server. Same with a put, lets you update data on the server. Slight difference between put and patch, which we'll discuss later. And also there is a delete verb which allows you to remove data via a request. So you can see it has all the basic CRUD, create, read, update and delete functionality that you may want to have as an interaction with a web API. So this is what you get out of the box, and as you can see also, if we just lifted this address here and placed it in a new window, we would see the same thing, but we would see it in not such a readable format. There we go, so we just get the JSON back. So that's all good, so we can close this a second, and the last thing we're going to do in this getting started video is just clean up this project. So we don't need this weather forecast, so we're going to get rid of it. And we also don't need its controller, so we can get rid of that as well. So at this stage, if we run it again, nothing would happen because we haven't got any controller, we haven't got any data. All we've got left is our settings file and the program CS file. The program CS file is basically where we configure up the web API service and plumb in all the middleware that's required to make it work. So we can have a look through this. At the moment we have got things like enabling SwaggerGen. The SwaggerGen is this open API documentation that you saw to try out the weather service that comes out the box. So we're configuring that up. We're also saying that if anyone sends us a request via HTTP, it will redirect it to HTTPS. So a secure socket. It's also got some use authorization stuff which isn't really getting used at the moment, and then it's also mapping the controller requests. So what that means is someone enters an address and that address maps to an action inside a controller. So that's what that handles there. So this project is where we will put our controllers. So going back to the MVC model, in our shared project we added our models, or started adding our models. In this project we're going to add our controllers. The job of the controller is to be an orchestrator. So someone will type in a URL, hit that URL will map to a class or a controller, and in turn will also, based on the verb that is getting passed in with, get, put, post, patch, delete, will select the correct route to a method within that controller to go off and do something, normally to provide a model and do some sort of business logic and return that back to the user. So with their web APIs, we've discussed that we have a model that I've just happened to put in a different class library. We'll have controllers that will be in here. You're saying, well, where do views go? Now views is a bit of a strange one for web APIs because views are all to do with user interfaces. So with a web API is interested in submitting and retrieving data. and behind that data there may be some complicated logic that goes off and decides how it gets that data and all sorts of things. So all it really returns is data, and that data can be in different formats. It can be in JSON, can be in XML, can be in a format that you specify, a custom format, but there isn't really a user interface that comes back. So the V part of MVC is a little bit misleading here. You could argue that the V part really is the JSON or the XML or whatever format that you're passing back to the client application that's going to consume it. There won't be a views folder in either this project or this project. So there's a little aside, but I thought that was worth mentioning. The next thing that we need to do is we need to link this project into this project so that our SMS API has access to our models and our logic. So how you do this is you right click on dependencies and you add project reference and you go SMS shared, go OK, and that now has added a reference into our API project. So now it will be able to access fixtures and players at the moment. The last thing I want to do to end this video off, and that puts us in a good position for future videos, is just to create an initial stub of a controller. So we can have one controller for players and one for fixtures. So just to end this video, I'm just going to create a players controller, and that's where we'll come to a nice pause for another video. So in order to do that, we click on the controllers folder, we right click and we go add controller. In the dialog that comes up, we want to pick API. We want to pick API controller empty. Click add. And the convention for controllers is the data that you want to return. So in our case it is a player. And it always ends with the word controller on the end. So player controller. If we go add, that will add in a stub for us. Again, I'm going to change the to file scoped namespace. And what we've got here is we've got a basic stub that's basically a class, but it inherits from controller base that lets us do a few special things with the HTTP calls. You'll also note that it has a couple of attributes. As an attribute that's identifying it as an API controller, so it'll behave like an API controller. It'll have a route. So basically the route is saying when a user types in a certain URL, it will map to that route. So we can see that in a minute. So what I'm just going to do now is I'm just going to create a dummy method inside here so you can just see it working, and we will come back in future videos to actually flesh this out with proper code. So our new method will be public action result. And we're just going to call this get data, and we're going to decorate this with the verb HTTP get. So this is saying go and get some data from the system, and all this is going to do is return a message. Okay, so nothing to do with players at this stage, it's just to see if we can get something working end to end. So what will happen, we can explain the routes a little bit better when we run this up. So let's just check this all builds. And it does, we build to success. And now if we run this up, our Swagger, hopefully our Swagger documentation should pick up that we've got a new player controller, which it does. The weather one has disappeared, and you can see that if you type in this address up to the port number localhost :7064/API/player, that is the URL that a user would enter, it will map to our controller. So what I'm going to do just to prove that is I'm going to put a breakpoint in the code, go back to our page and try it out. So if we go try out and then go execute, you can see we've hit our endpoint. So it's come in API controller is player, which is this bit here. So that's what it's hit, and then it's recognized that we are trying to use the get request, so it's hit this method. And if we step and return, go back to the code, scroll down, and you can see we've got some data back from our server with a 200 code, which is good. So with sitting on top of the HTTP protocol, we can make use of the HTTP status codes. So whenever we get anything with the 200 range, that means it was successful. When we get, can't remember what a 300 means at this stage, we can look that up. In fact, let's do that now. So here we go, Wikipedia to the rescue. So 300s are redirections, don't tend to use them a great deal. This class of status code indicates the client must take additional action to complete the request. So like I said, don't use those very often. We can get into more detail if needs be as we go along with these, but what you're more likely to use are 400 codes. 400 codes, so a common 400 code most people will be aware of is when you hit a web page that no longer exists, you get a 404, which is a page not found. You may also get other 400 errors, for example, when you need to log into your API. And if you try and hit an API without successfully logging in, you'll get a 401 unauthorized. We can also send back requests of when someone passes us some data that they're hoping to save into our system or database in the back end, but it's not correctly formatted. We can send back a 400 bad request. There's several other ones as well. Those are the most common ones of 400s. I've often seen a 409 as well, and also 415s, unsupported media types. But yeah, 400 is quite common request to come back. It means basically something's gone wrong. Then the final ones that you see, and these are the ones we don't like, are 500 errors. 500 errors are, there is a pretty fatal server-side error. Bad gateways, can't get through for some reason. These often happen when there's something fundamentally wrong on the server side. The server is down, the server can't speak to the database, we've lost connectivity, something like that. So those are the basic codes. The thing that we're always happy to see is when we get 200s, be they 200, which is a straight OK, I think, if I remember rightly. 201, so we get 201 when we send some data that we want to get saved to our system or database. If it works, we get a 201 created, for example. So 200s are good, 400s are helpful errors, 500s are bad. 300s we don't really use very much. There's also 100s as well, which I've never ever used, so I don't think you need to particularly worry about those either. So this is probably a good point to stop, because we've now got a structure set up. We've got basic web API working, not providing us with particularly useful information at this stage, but the learning outcomes from this video is that we now have a project, a solution set up that has two projects, has a shared project that is handling currently our models part of the MVC. We've set up some folders for future topics we're going to talk about at a later date. We've also created this project, the SMS API, which is basically our web API or RESTful web API project that is making use of C# methods that are matched against HTTP verbs. We've referenced our shared project in our SMS API so that we have access to the models and all the other richness that will be in this reusable component at a later date. We've created a basic controller called player controller that's just returning some dummy data at this stage, just using a simple HTTP GET. We briefly had a look at the program CS file that configures up the web API and all its middleware pipeline. We've just used the stuff that is out the box at this stage, but this can get configured for a lot more things, and we will be coming back and making additions to this as we progress through this series. We've compiled it all to make sure it all works. And finally, one of the things that we can get from the web API template out of the box is that we can get this useful Open API or Swagger documentation. This is very powerful and very useful because, one, it provides us with the UI to play and interact with our web API. It acts as documentation for our web API. And another thing that it also does is it allows us to create custom clients that can consume this web API by using the swagger.json document that gets generated. But we will go into that on our journey as we go further and further through this course. So for now, I think that's all I want to say for this section. So I'll see you in the next section.